Okay, looking at this problem, we're going to want to use implicit differentiation to find the answer here. So we'll take the derivative of ln 2y, and so that's going to be 1 over 2y times derivative of 2y, so that's going to be 2, and then you always have a y prime when you're taking the derivative of y, or you could write it as dy dx, either way, equals. Now here you're going to have a product rule. There's your first and there's your second. So the derivative of e to the y is going to be y prime e to the y, because the derivative of e to the y is just e to the y, and then you have the y prime because you're taking the derivative with respect of y with respect to x. And then that's times the sine of 5x, and then plus, you'll use the chain rule here to take the derivative of sine x, and so that's going to be 5 cosine 5x times the first, which is e to the y. Okay, now the technique on solving for these problems is to move everything with a y prime or a dy dx onto one side and then simplify. So before I do that, I'm going to cancel these 2's right here. So this is y prime over y minus y prime e to the y sine 5x is equal to 5 cosine 5x e to the y. Okay. Now, I'm going to factor y prime out of this side, and I get 1 over y minus e to the y sine 5x equals 5 cosine 5x e to the y. Now, on this stuff, I'm going to need to divide by this stuff, but before I do that, I should get a common denominator. So I'm going to multiply this by y over y. And so this becomes y prime 1 minus y e to the y sine 5x divided by y equals to this 5 cosine 5x e to the y. So then when I solve for y prime, I can multiply by the reciprocal here, which is just going to be let's see. Let me get another page here. Let me get some more room here. I'll have y prime on this side. And then when I multiply through by the reciprocal, the y is going to come up top. And so that'll be 5y. I'm going to bring this e to the y over to the front. So e to the y cosine 5x divided by 1 minus y e to the y sine 5x. Okay, and there you go.